All right, guys, sorry about this. This is not ideal, but I have to keep on going because I'm a little behind on my timeline. So anyway, today's lesson is about absolute value equations. Absolute value, that's what these little bars here are. Okay, so absolute value is a measure of distance from zero on a number line. So just so you know, like it can never equal a negative. Absolute value has to always be a positive number. I always use the example, like even if I'm going in reverse, I'm still going somewhere. So when you're solving absolute value, the first thing you want to make sure is you isolate the bars, right? Isolate the absolute value bars. That just means get everything that's on the side of the equation with those absolute value bars outside, away from it, okay? So if you look at number one, this is already isolated. There's nothing outside. So once that happens, then you're going to make two cases or two equations. One equation is going to be just what you see here. X plus 4 equals 10. Your second equation is going to be the same thing that's inside your absolute value bars, x plus 4, but now I'm going to set it equal to negative 10. Okay, and then I just solved both of those. So you're always going to have two answers unless it equals 0. So my steps would be to subtract 4 from both sides, and I get x is equal to 6. Subtract 4 from the second equation, and x is equal to negative 14. Those are my two answers. All right, there's always going to be two answers for absolute value unless it equals 0 or unless it's like number 2. It's isolated, there's nothing outside, so I'm ready to go. But then I'm like, uh-oh, it can't be negative. It cannot be negative. If that happens after you isolate and all of a sudden you notice you have a negative sign on the other side of the equation, this is a no solution situation because distance can never equal a negative, okay? And so you know, for this video, you can pause it, but I really would love it if you could copy these problems down and put them in your little composition book that you have. I have the paper to glue in, but you can write it. There's only 6 questions here. All right. So number 3 is a special case because, okay, 1, it's isolated, but now it equals 0. So I can't have positive 0 and negative 0. There is no such thing. So there's only going to be one answer in this case. So I subtract 7, and I get x is equal to negative 7. That's it. That's the only solution that can be if the absolute value once isolated equals 0. All right, let's look at number 4. Number 4 is not isolated. I have to get rid of this. I'm going to get rid of negative 6 outside of the bars. How do I get rid of it? I add it to the other side of the equation. So now I have absolute value of 2x plus 5 is equal to 23. All right, now my bars are isolated. All I need to do now is make my two equations. My first equation is exactly what we see here. 2x plus 5 is equal to 23. My second equation, 2x plus 5, is always going to be the same stuff that's inside the bars, but now I'm going to set it equal to negative 23. All right, this is a two-step equation, so I have to subtract 5. 2x is equal to 18. Divide by 2. X is equal to 9. Second equation, the steps are exactly the same. Only my answer is going to be different. Subtract 5. 2x is equal to negative 28. Divide by 2. X is equal to negative 14. Those are my two answers. 9 and negative 14. All right, 2 more equations to go. In number 5, I have to isolate the bars. I want to do this first, and then I'm going to get rid of this 2 second, okay? But I need to isolate the absolute value bars. So we get rid of the negative 7 first by adding 7 to both sides of my equation. Gone. All right. Now, I know sometimes people want to subtract 2, but so you know, for the record, there is a multiplication dot in between that 2 and that bar, okay? So what's tying that 2 in front of that absolute value bar is multiplication. How do we undo multiplication? We divide. Divide both sides by 2. Now I have absolute value of x plus 5 is equal to 9. My absolute value bars are isolated. I can make my two cases, or two equations, I should say. X plus 5 is equal to 9. X plus 5 is equal to negative 9. This is a one-step. This is super easy. Subtract 5, x equals 4. Subtract 5, x equals negative 14. Those are my two solutions. All right, one more to go. The absolute value bars are not isolated. It's currently being divided by 3. What's the opposite of division? Multiplication. Multiply both sides by 3. Do not distribute. Do not distribute into the bars, ever. All right, never, ever, ever do that, okay? So I multiply both sides by 3 because this 3 cancels out that divided by 3. I can bring down my absolute value of 2x plus 4, and now I'm going to set it equal to 30. Absolute value bars are isolated. I can make my two equations. 2x plus 4 equals 30. My second equation, 2x plus 4, now it's going to equal negative 30. Okay? Two-step equations. You guys know how to do these. We're going to subtract 4 here from both sides. 2x equals 26. Divide by 2. X equals 13. Second equation. Subtract 4 from both sides. 2x equals negative 34. Remember, a negative minus a negative is a bigger negative. Divide by 2. And x is equal to negative 17. There I have it. Okay? So that are your 6 examples. You should have these written down in your composition books. I will be checking them tomorrow. And then please complete the 9-2 assignment for today, absolute values. All right. And then, let me know if you need any help or if you have any questions. I'm going to be on Zoom for the whole hour from 10 to 11 for you guys. And then I also have Remind if you need any help there. Okay. All right. Have a great day. Bye. See you tomorrow, hopefully.